quiz and what you're expected of by this point in time in this class right here. Now, always look at the directions. I got 0 to 2 pi. Now, sometimes you might see it written like this. You understand how to read that, don't you? Is everybody good on that? So it can be written like this or like this. Now, if they didn't have that line under that less than, would you include 2 pi? Okay. Number 1, do we have one trig function? Can I isolate it? It's already isolated, isn't it? Do I want to work with cosecant? So which one will I change it to? Sine. So I'm going to change that to sine. Sine theta. And when I do that, I got to flip it. Gary, can I leave that root 3 in the denominator? No. So I'm going to multiply the numerator and denominator by root 3. That gives me 3 times 2 is negative 6. Does everybody see how I got negative root 3 over 2? Simplify the 3 and the negative 6. Okay. So I want the sine. Is that your x or y? So what family am I dealing with? Pi over 6 or pi over 3? Pi over what? Pi over 3. Your y value is negative. What quadrants am I looking in? 3 and 4. What pi over 3 families or members are in 3 and 4? 4 pi over 3 and... Very good. All right, number 2. Can I combine that sine squared and that 2 sine x? Look at me and pay attention. Can I combine sine squared and 2 sine x? No, so I have to do what here? Factor. Do you understand that? Okay, so that looks very similar to easy. Factoring right there. So I'm going to let u equal what? Sine x. U equals sine x. So here I go. U squared plus 2u minus 3 equals 0. That's going to be u plus 3 and u minus 1. Now I'm going to put sine x back in for those. Sine x plus 3 equals 0. Sine x minus 1 equals 0. When I move that 3 over, it becomes a negative 3. Do I have a sine value of negative 3 anywhere? So do I need to worry about that? No. Move this over. Sine x equals 1. Where would my y value equal 1 on the unit circle? Pi over what? Pi over 2 at 90. 0, 1. Okay? So your only answer is pi over 2. Number 3. Can I combine a cosine squared and a cosine? No, so I have to factor. Okay? I have to factor on that. What can I take out of that? Cosine theta, thank you. So cosine theta, that's going to be 2 cosine theta plus 1. Now I'm going to ask you this. What if it was written like that right there? Would you have to bring that over again and set equal to 0? If you got to factor it, it's going to be set equal to 0, okay? Is everybody clear on that? Okay. So now I'm going to do cosine theta equals 0. 2 cosine theta plus 1 equals 0. Where on the graph is my cosine equal to 0? Quickly. This should be quick. Pi over 2 and what? Thank you. Move this over. Divide by 2. What family am I dealing with here with cosine of negative 1/2? Pi over 6 or pi over 3? Okay, this should be automatic. What is it? Everybody, what is it? Pi over 3. Thank you. I need to hear that. Okay. If x is negative, what quadrant would that be in? Quickly, what quadrant? 2 and 3. Okay, so you're dealing with 2 pi over 3 and 4 pi over 3. I need some energy this morning now, guys. All right, number 4, last one. I got a 4 sine x and 2 sine x. Can I combine those? So would I factor on this one? No. Two sine x equals square root of 2. divide by 2. Did you take the square root of this? So do you need to have the plus or minus? No. Okay, that's the pi over 4 family. Your sign is positive. It's your y, quad 1 and quad 2. So you got pi over 4 and 3 pi over 4. Are we good on that review? Did that help you clarify everything? We good, Jackson? Okay. You better show me tomorrow. Alright, let's turn to page 15 now in your notes. Very good. Okay. So today, guys, look at our learning target. It says, I can use sum and difference formulas to determine exact values. Okay, up to this point in pre-cal, you've dealt with stuff that you found on the unit circle, like sine of 135, cosine of 300, tangent of 60, and all that stuff. Stuff that we could easily find. Well, now I'm going to give you stuff that's not on the unit circle. You know 15 degrees? You know 75? You know 7 pi over 12? No. So none of these will ever be on your Triggy Tuesday stuff, but you have to know that Triggy Tuesday stuff in order to do this, okay? That's why we've been doing it all year. So let's think about what this target says. I can use sum and difference formulas. So what do you think, by me saying sum and difference, that you could do? Add or subtract what? What do you think we're going to use? The what angles? Which ones? The reference. You know, we talk about 30, 45, 60 or 740. Also, those points 90, 180, 270. You're going to use those numbers to add or subtract them to give you these values. Does that make sense? So the only time you use this is when I give you values that's not on the unit circle, okay? So that's what we're going to use today. And I'm going to let you have a note card for this test because 1, 2, 3, 4. You're going to have 6 formulas this week, and you got 6 more next week. So you have 12 formulas. So you have index cards. I need to give you index cards. Let me give you some index cards. Now you can write these on them later because they're at the top of your notes. We're not going to take time right now to write them, but I'm going to give you an index card. If you don't have an index card on the day of test, you're bad.
Are we just going to have a test, just memorization?
No, I would never make you memorize those. I was never taught to memorize those. The ones that we had the memorization test on, those are way more important things. I'm going to pass these index cards around, and you just grab one, and you can write these later, okay? All right. Now, let's talk about what they mean. Look up here. Look here. So let's say this. Let's say I was combining 30 and 45. 30 and 45. Alpha and beta are just variables, okay? So let's say I said 30 plus 45. How to read this formula? That would be the sine of the first one, which would be 30, cosine of the second one, which I said was 45, plus the sine of the second one and the cosine of the first one. Do you see how that works? Here, alpha minus beta, sine of the first one, times the cosine of the second one, minus sine of the second one times the cosine of the first one. Does that make sense? How to read that? We will see it in a minute, okay? We're going to say that again. Cosine, you take the cosine of the first one times the cosine of the second one, minus, even though it's plus in the formula, it's minus sine of the first one times the sine of the second one. The difference is the same, but you just put the plus. Now this is where tangent gets a little tricky here. Tangent's a big old monster here. Okay, let me explain it to you over here, and then I'm going to explain to you what that symbol you see here. Tangent's alpha plus beta. You take the tangent of the first one plus the tangent of the second one divided by 1 minus the tangent. Subtraction, tangent of the first one minus tangent of the second one over 1 plus. So you say, Mr. H, I've never seen this symbol right here, that minus over plus. Well, the symbols go with whichever one. Like you see here, the plus is on top here. So in the first form you will have plus, and then the minus is on top. The minus goes first. So in the first form you have plus and then a minus. Second formula, you got a minus and then a what? Plus. Do you see how that works? That's how you read that symbol. Okay? I wrote it out over here so you can see that.
Why is it?
It's just a set formula. It's a set formula years ago that the mathematician came up with. Okay? So here's your formulas. All right. It does matter, so don't just pick whatever formula you want. You will get the wrong answer. All right, so on number 1, we're going to take this one slowly. I want to find the exact value of cosine of 15. Okay, so what you need to do, and guys, what I would do on this is I would put some values up here at the top of your paper as some reference. Thinking about it. Now, you're not limited to these values. You can use any value on the unit circle, 135, 150, whatever, but most of the time it's going to be these. But it's not always, but most of the time, okay? How could I get 15 out of some of those numbers?
45 minus 30.
45 minus 30. What's another one?
60.
Wait. Somebody said 30 minus something. What? You can do 45 minus 30 or what? 60 minus 45. You're going to get the same thing, but you have options there. What comes to my mind is 45 minus 30. I'm going to do that one first. Okay, so watch how I want you to do this. I'm going to put equals. This is exactly how I want it to on your paper. Cosine of 45 minus 30. Because 45 minus 30 is 15, isn't it? Now, you say, Mister, what if I put 30 minus 45? Is 30 minus 45 15? No, that would be wrong. Okay? All right, now, watch how I handle this. So I got a cosine, I got a minus. So I'm going to use this formula right here. It says take the cosine of the what? First one times the cosine of the... Okay, so let's do that. And then what symbol? Plus. Plus the sine of 45 times the sine of 30. Now, I don't know why I didn't just put the parentheses here and here. I don't know why I just put it on 45. But you know what I'm saying. I'm multiplying this quantity times this quantity. So let's stop right there. Everybody understand how I set that up? Now, this is where your unit tree comes into play. You've got to know your tree. What's cosine of 45? Square root of 2 over 2. Cosine of 30. Square root of 3 over 2. Now, what is square root of 2 times square root of 3? Square root of what? Colby, you can turn around and make yourself as comfortable as you want. Okay. All right. Square root of 2 times 1 is what? Square root of 2. Now, I'm adding fractions. Do I have a common denominator, guys?
Yes.
I know that I cannot add square root of 6 plus square root of 2, but could I put it over the same 4? Could I write it like this? This is how I would prefer your answer. That is your answer to that problem. And you're done. So, your exact value, that's why it's called exact value, because if I found the square root of 6 plus square root of 2 and rounded, does that give me the exact value? No, but that's the exact value, okay? No. You can't take 6 out. Yes, it's tempting to take a 2 out, but isn't 2 and 6 under the radical? Yeah. Okay. Are we good so far? Let's try another one. sine of 75. Of those two reference angles, which two reference angles give me 75? You could do 90. Wait. Okay. Would not do 90 and 15 because you don't know 15, do you? So which two stands out to you? 45 and 30. Okay, so let's do that one. Now, you might be saying, Mr. Fisher, how do I know which one? Does order matter in addition? So if your friend put 45 first and then you put 30, you put 30 and then 45, it doesn't matter. You're going to get the same thing on addition. But subtraction, you have to be very careful, okay? So sine of 30 plus 45. So if I look at my sum here, is sine of the first one times the cosine of the second one plus the sine of the first one times the cosine of the second one. Does that make sense how that looks with the variables? Okay, so let's go with that. So it's going to be sine of 30 times cosine of 45 plus sine of 45 times the cosine of 30. Take a moment to look at that and make sure you understand how I got that set up. The setting up is the hardest part. Okay? Are there any questions so far? What's the sine of 30? 1/2. What's the cosine of 45? Sine of 45. And cosine of 30. I'm adding fractions. I have a common denominator. You said, Mr. Chester, we just got the same thing pretty much. You're going to see a lot of square root of 2 plus square root of 6 on these. I'm just going to tell you. Just don't think everyone's going to be like that, but you will see the square root of 2 and square root of 6 up here a lot, okay? But that is your answer for that. All good so far? The next thing, you start seeing fractions. We didn't learn anything about pi over 12, did we? But what I'm going to tell you, what I found that's beneficial for myself and for students is to go back up to your reference angles. Okay. Well, let's go to the side right here. Let's just go to the side. We have 30, we have 45, and we have 60. What is the radian for 30? Pi over 6, okay? What is 45? Pi over? And 60 is pi over what? I find this beneficial if you go on and do this at the top of your page as well. What's the common denominator between 6, 4, and 3? 12. 6 times 2 is 12. 2 times pi is 2 pi. 4 times 3 is 12. 3 times pi is 3 pi. 3 times 4 is 12. 4 times pi is 4 pi. When you have those already in the denominator like that, can't you easily figure out now what is equal to 7 pi over 12 or 5 pi over 12? Go on. What I suggest you do on these problems is go and list your reference angle at the top of the page and in radians and go and find that common denominator. Because when you have this at the top page, it's easy to say, okay, 3 pi plus 4 pi is 7 pi, isn't it? So you already found out that these two are what you're going to use to get to that. Does that make sense? So I always tell students to go and put your fractions across the top. So here, it's going to give me 7 pi over 12. Well, I'm going to use 45 and 60. So sine of pi over 4 plus pi over 3. You say, Mr. Chester, why don't I use the 3 pi over 12 and 4 pi? You don't want to use those in here because you use these to help figure out what gave you that, but you got to use this to do the trig. Like you don't know the sine of 3 pi over 12, but you know the sine of pi over 4. So I just took these two, but kept these and put that there. Does that make sense? We good, Derek? Okay, now, I'm going to use my sine formula. Right here. Sine of pi over 4 times the cosine of pi over 3 plus the sine of pi over 3 times the cosine of pi over 4. What is sine of pi over 4? Cosine of pi over 3. Sine of pi over 3. Root 3 over 2. Cosine square root of 2 over 2. Once again, you get square root of 2 plus square root of 6 over 4. One more, I'm going to call it a day. Cosine of 5 pi over 12. Which of those do I need to add or subtract here? Add. Which ones I need to add? Because 2 pi plus 3 pi will give me 5 pi with it. So I'm going to add the pi over 6 and pi over 4. Order does not matter in addition, so I'm going to go cosine of pi over 6 plus pi over 4. And I'm going to use this formula, cosine. I'm going to use this formula. Cosine of pi over 6 times the cosine of pi over 4 minus the sine of pi over 6 times the sine of pi over 4. Cosine of pi over 6 is square root of 3 over 2. Cosine of pi over 4 is square root of 2 over 2. Minus, that's going to be 1/2. Didn't I tell you you're going to see a lot of square root of 6 and square root of 2? And that will be your value for pi over 12. We just did sine and cosine changes. Tangent takes a little bit longer. We're going to do tangent tomorrow. Looking at your assignment, once you're done with that example, please look up here, over here. That wasn't too bad today, was it? Okay. Your homework tonight is page 19, 24 to 29. This practices some more tree equations, like what your quiz is on. I'm only giving you 2 problems that deal with this tonight, okay? But I want to change something, so I want you to look at numbers 34 and 35 on page 20. Make sure you have your page 19 down, 24 to 29. Page 20, numbers 34 and 35. On number 34, I want you to change that to sine 15. Because cosine 15 is what we did in class, so do sine of 15. And on page 20, change number 35 to cosine. So you got page 19, numbers 24 to 29. Page 20, number 34 and 35. Change 35 to sine, change 35 to cosine. Are there any questions? Change it to sine, change it to cosine. That's not massive Barbie.